In today's webinar, How to Easily Improve Quality Using Automated Visual Inspection, brought to you by Baumer and Design World magazine. We'd like to thank our presenter, John Schwinnard, for being here today. I'm Michael German, Assistant Editor for Design World, and I'll be your moderator. Just a couple quick housekeeping details before we get started. If you wish to tweet about this webinar during or after, you can use the hashtag DWWebinar. This webinar will be available afterwards via email and through our website, www.designworldonline.com. There will be a Q&A session after the presentation, so go ahead and submit your questions in the question box on your GoToMeeting control panel, and you'll ask them after the presentations are finished. Let me tell you a little bit about John Schwinnard today. He's currently the Vision Technologies Eastern Region Sales Manager for Baumer in the U.S. He's been involved in machine vision and imaging, been involved in machine vision and imaging since 1990 and is intimately familiar with many aspects of industrial imaging. And as I said, John will be available to answer questions after the presentation. So without further ado, I will hand the mic over to John.
Great. Hey, thanks, Michael. You hear me okay? Michael?
Yeah, I can hear you.
Oop, okay, great. All right, great. Appreciate everybody attending today's webinar here. So again, my name is John Schwinnard. So kind of walk you through today, main topic at hand here, talking about how we can use vision sensors to help with quality. Go through several different aspects with you here. So just as a takeoff here, just to understand who Baumer is, we're really a global industrial sensor manufacturer. On the main side here, we're really about today is some of the vision sensors. Within the portfolio itself, though, it's kind of interesting because we really do a lot of industrial cameras for many, many, many years and working now on a lot of the vision sensor type technology. And aside from that, looking at discrete sensors, motion, and several other products that's within that line here, but really located in the U.S. to help support you guys locally here. So a little agenda for today. We're really going to take an introduction to vision sensors. And what I really want to do is for the folks who are here who are really new to this technology, really new to maybe cameras and technology in general and how things operate from taking a picture to the actual processing to it, give you a little introduction of vision sensors so you can understand that. The one key important thing here that we really want to talk about is really lighting. You'll hear me talk about this several times during this presentation. I'm talking about how lighting is extremely important, how lensing is extremely important, and those are kind of the key things that we have here to really help us gather that image that we're going to do some processing on. And go through a good handful of applications just so you get some sense of the different types of applications that are really truly suited for vision sensors, aside from doing other types of applications with other sensors or maybe even looking at PC type vision. And then lastly, go through how to really configure a vision sensor. And that's some of the key things here that we'll show you really how ease of use can be done to really help improve some of the quality on your lines. So to the right here, you'll also see just so you have some sense if folks have not seen what vision sensors actually look like, a couple of representations of two different ones that are here with integrated lensing and one with regular C-mount lensing. We won't get so much into that today, but it's basically, think about it as your SLR camera and the different lensing we actually need to actually gather the certain field of view that we're actually looking for. So if we think about what is a vision sensor, we'll just first start this back to what is actually happening with some of the technology so you can understand this, because it's pretty important of how we're looking at this of doing the image analysis. Really, we've got a camera here. We've just like your cell phone, we've got a sensor that's in there. It's a CCD or a CMOS type sensor that's here. And it really is an array of pixels. So when we just talk about our cell phones and we've got a 5 megapixel type phone, it's an array of pixels that are in there. So represented here is really looking at a 2 megapixel type camera where we've got an array of 1600 pixels by 1200 pixels, right? And so we're basically taking image to object, if you will. If you kind of look at the little diagram we've got down below here, we're actually looking at an object we're doing. We've got a certain illumination that's on that that's going to reflect back off of that surface. We've got a lens that's actually going to take that object and superimpose that now back onto the image sensor. And what's happening is we're actually taking some of the light that's accumulating onto that sensor, really the amount of photons that we've got there, this light energy, and it's actually charging up each one of those pixels to a grayscale level. So we end up resulting in each pixel getting a value of 0 to 255 grayscales. And in turn, that gives us a black and white image. We won't so much talk into color sensors today, which do exist. Most of vision applications today are a lot of monochrome, but really progressing further into color, which is a topic for another day. And then what we do after that is once we do have this image on the sensor, we're really applying some image analysis for this, right? So once we've got this, we're using some software. We're going to use some soft tools that we apply on top of that to really analyze that image. And so in essence, what we're doing here is really taking a picture, right? So if you kind of look at this little application that we've got here, where maybe we're just taking a look at quality of this, looking at this top cap, seeing that the dimensions from when it's popped up high versus where it's seated, we maybe want to identify is that a certain distance. And we can start to do that using vision and using some analysis. So if you look over here on the left-hand side here, really what we're doing is, as we talked about taking that array, we're taking those light values and actually changing those from 0 to 255. So in this application here, we really see that some of these values in the lower section here are a pretty high value, and they'd be probably pretty close to saturation of 255. And we're going to have some gradient here that maybe goes from the values of 200 and start to go lower, and eventually get down to grayscale levels in the top half here that are about 80. So what we're really doing is looking at using software and some algorithms that actually detect that edge. It's actually looking for that specific transition from the bright to the dark, and doing the same thing down here. So we actually drew two line tools, soft tools if you will, taking a cursor and dragging those across. It can actually help us find that specific transition. The key thing here again is going to be lighting, especially when we're doing measurement applications. Lighting is very critical, lensing is very critical, because the best thing that you want to do in these applications is trying to get the crispest edge that you can. So really we're talking image-based quality control. We're really going to take a good picture of something and really apply some tools and do some analysis. And we'll talk about some of this. So we'll really talk about how does a vision sensor compare low end versus high end, right? Because we have various vision sensors and vision systems that are out there. On the very low end here, and we take a look at this little graphic here that's talking about application costs going up and really looking at sensors versus vision systems. And it's really PC-based vision systems. Sensors in the lower half of things are just very basic binary, if you will, devices that can give us basically one type of application that we might be looking at. Versus on the very high end, we're really talking about PC vision, right? We've got a PC involved. We've got some processing power that we need. We maybe have multiple cameras, as you've seen here, connected to this, and really have a lot of complexity that we can do. PC-based vision will get into some programming. You'll get into more complex algorithms. You'll have some pre-processing, advanced logic, etc. Tons of places for this. There's also a lot of places for what we're going to get into and talk about vision sensors. These are really a nice fit that's come in through the years. A really ease of use is the main key thing here. A good abundant amount of tools. So in typical cases, in these cases here, we're looking at 5 to 20 tools that we can use, and we'll go through some of these tools. Multiple resolutions now from VGA up to 5 megapixel. Again, limited a little bit in the pre-processing and the logic though. But the main key thing here, and I wanted to bring out some images for you just so you can understand this, is really lighting is very, very, very key. Most thing I always tell folks is really programming the vision sensors themselves is really typically the easiest part. Your biggest challenge that will lie out there, and you can rely on guys like ourselves and other people in the marketplace to really help you understand lighting and lensing. Little example here when we take a look at this and just saying, and most folks will tell us have been around vision for a while, is lighting is really 80% of a vision application. Garbage in equals garbage out, right? And it really comes down to creating contrast. So if we look at this example here where we're looking at a product and we're looking at the barcode, or maybe we want to read some characters that are on there, this image on the left is taken with a light that's put in the proper position, and it's getting rid of the direct reflection and the glare that you've got back. Versus on the right-hand side here, we might turn on some vision sensors, has a light that's built into it, and it's just glaring back at us. We obviously cannot process this, but we can also process this. So lighting is going to be very key. The big bottom line there is really to help create contrast. So another example here is maybe we want to do a pattern match on this front of this bottle. Might want to look at a label. We can do an application like this and looking at skew of the label, make sure the label is correct. Is it the right label on the right container, etc. Again, similar to that type thing here. If we have a ring light that's here versus actually doing a light in the appropriate position, night and day, and what we're going to be able to see, right? And actually, you can see if you pretty tough on some of the monitors you may be looking at here, but some of the differences here where we've got 0% difference in this versus a really change in a lot of the pixels that we got here, that's probably up to 30 to 40% change. So let's talk about how can we really improve quality using the automated visual inspection. Really look at the types of applications, and I'm going to run through about a good dozen applications just to give you the appetite of what the type of applications are out there and talk about some of the things that we can do. And then after that, once we have grabbed an image, got parts coming down the line, what do we do with this information, right? Can we do something where we want to put it out to a stack light? Do we want to do a reject mechanism, et cetera? Do we want to collect some of that information? And there's different things that we'll talk about on what happens at that point. So if we look at just a big general overview here on different applications that we can typically tackle, again, talking more about vision sensors that are here, is really looking at a variety of different categories that we can discuss here. Talk about presence and completeness. So we might look at verification, and verification could be anything from looking at components that are placed down on a PC board. Are they all there? Is there an assembly that's put in place before it's going into a press application? Things of that nature. Left-hand part versus right-hand part. Has it been assembled correctly before it goes on? And get into measurement. Measurements really is as simple as it sounds, is looking at some dimensions of something. And we'll actually do some gauging before we do that and some calibration to be able to get to a real good measurement. Again, lighting and lensing is very, very critical when we come into measurement. And assembly attributes. Could be, as I mentioned, anything where we're looking at an assembly that's coming down a line. We want to make sure that all the different parts that are there before it goes on. Is there a cap on the pen or whatever it might be? Is there a cap in the bottle? Things of that nature. Location and correct position. We can basically get X, Y, and rotational values out of the vision sensors. So it might be a case where we do have something that has been rotated in a line, should be in a certain position that's there, and maybe look at the rotation that's there as well. So we can take a look at those things. It can actually also tie into robotics as well and see if there's something on a conveyor belt, pick its X, Y, and rotational values out. Look also at human readable codes. So we might look at character, verification, and recognition. So we're talking about OCR and OCV. And you might hear those two things that are out there, and that's basically what we'll talk about and show some examples there. The other one, too, we'll take a look at is reading of non-human readable codes. So this is really talking about 1D codes and 2D barcodes. There might be specific sensors in general that may be used for these as well. And I'll show an example where I combine 1D with some OCR. So it may be a specific device and vision sensor you look at to be able to do that type of application. So let me go through a couple different applications you'll see here in the various type of categories. First one, looking at presence and absence. So this might be one here that we're looking at. This is actually a little juice box. And this juice box down here has a straw that's in here, and it's cellophane wrapped, right? And so this is a good juice box on the right-hand side. On the left-hand side, we've got some issues here where the straw is sticking out, or a case scenario here, as we see this thing, the straw, and it's really impacted into the box. We'll apply some tools that are on here, what we did with this, and I'll talk about the tools and what the digital outputs that you'll see for each of these guys. And so this one here, we actually did a little pixel counting. So what we're really looking for is in these areas in the pink that's here, is actually looking at pixel values that are above a certain threshold that we set. If we actually have that certain number of pixels and we have the light correct, we'll actually get a reflection off that and tell us, yep, we actually have a straw within that cellophane package. And you can kind of see here by this little bar that's here, we're way up in regards to the number of pixel count that we've got, and we know we're good. And we're going to set some tolerances on that through some little bit of application work. If we're actually missing, we're not getting any bright pixels at all, and we go bad, and so we'll end up doing an output here. So we'll work on doing a digital output in this one here, where we put an output to one of several different digital outputs to say that we've got a bad part and help reject it. Another one here looking at presence and absence. This was interesting, a little bit of a setup diagram on the right-hand side. It's actually just like a baby jar lid. And what would happen in some of these cases is that we have some compound during the manufacturing process that gets into part of the surface. So what we're doing here is really using some of the soft tools that we've got. We'll actually use a locator tool, so parts don't always have to be exactly placed. We can actually have things rotating 360 degrees down the line, and then pick a region of interest that we want, look within that region of interest, and see if we have some changes in the pixels that are there. In this case here, we actually looked at the actual location on circle and actually counted the areas within there to see that we've got either presence and absence of any compound that's there. And then in turn, give a digital output, and if it was bad, we can put an output and put a reject mechanism. Another one here, presence absence. This is a little part that had been manufactured, and it was actually coming down a flexible conveyor type line, and through a rotational bowl and then positioned to a certain point that it was going to get picked up with some mechanics. And what we really wanted to see is on this one here on the right-hand side, we actually see there's a little indentation that's there. Versus if it was flipped over, there's no indentation whatsoever. So we really want to locate that and see if it's there or not. If it's not, we're going to do something different. So in a case like this, we can actually use some tools. We can locate the part, and actually we can look at counting contour points. So in a case like this where we're actually lighting this up, the actual circle that's here that's in an indentation is actually giving us a transition. And we can actually look at that transition, look at each one of those pixels, and say those are actual contour points. So if it is present, we'd actually have a contour point that's about 143 points. If it's completely missing, we're going to have pretty much next to 0. We had 12 points in this application, and that we just lit this up in a very basic way. Once we have better lighting, that would be probably less than 5. And we can see the difference between those two, give it a digital output, and see if we've got the part oriented correctly. Let me see those. There we go. So presence absence, another one here. This is helping identify if a label is present and there's a rod actually put in the center. This was actually on a rotary index table, so the positioning was very, very accurate. Had the vision sensor looking at the actual application itself. And so what we want to do is see, is this label here, and is this metal rod stuck through the part before it goes on the rotary index table. So in this case here, we didn't have to worry so much about locating tools to see this because it's well fixtured. But we basically used a tool we call a count areas tool. And essentially what we're doing is defining how many pixels do we actually want to see of, say, dark pixels that's here, using a threshold that will tell us we want to be above or below a certain grayscale level. And then a second tool that's here that's actually looking at certain grayscales and making sure there's a certain percentage of them. On the right-hand side, we see that our label is missing. We actually have a lot more darker pixels than the average bright pixels that we should have, and in turn that's going to go bad. And again, in a case like this, we can do a digital output and tell that it's incorrect. Another example here, looking at completeness. So this is just an example. Completeness could be a variety of different applications that are there, but just to share this one application. Maybe looking at a barb that we've got when we were manufacturing some barbed wire. We ideally want to have some points that are sticking out on that barb, and we want to see that they're there. So we can actually use a tool, draw the line tool across this, and actually do something where we're going to actually count edges. So in a case like this, I can actually go from the transition and look from transitions from bright pixels to dark pixels. Again, bright to dark, and the same thing on a duplicate tool on the bottom. Ideally, I should see 2 transitions. On the right-hand side, if I have some things missing, actually have no transitions on the top one completely, then we've got an error, and we can in turn put a digital output to that. So here's where we get into a little bit of measurement. And again, as I mentioned, measurement gets really critical when we start taking a look at the right lensing and lighting. And if we looked at that first diagram of how we're looking at that transition of how it goes from bright pixels to dark pixels, the ideal thing with measurement is that we really want to do that transition relatively quickly. If we don't, we're going to be in trouble, and we're not going to have as accurate of a reads as what we'd really like. With real measurement applications, we can actually really get down to some pretty tight tolerances that we can get to, but it comes down to field of view, resolution, the right lighting, the right lensing. So in this case here, we wanted to look at this cap and see that it's on right. So we actually put some tools that are on here that are looking at the top of the transition of the cap, bottom transition of its seating surface, and we use the underneath neck that's here. We did that on both sides, and so we basically have two distance tools that have been placed onto this. With any of the tools, you're basically setting a tolerance. So we can set this tolerance to be whatever it might be. In this case, we're within plus or minus 5/1000ths of an inch, and tell if it's good or bad. So in the one on the right-hand side, we were actually unseated just a smidge. Actually on the right-hand side, unseated a little bit. On the left-hand side, it was okay, versus the left-hand side one is completely bad. Another measurement one here, looking at a key. Again, lighting, lensing, very critical here. We actually got to some very, very tight tolerances within this. And again, using the right lighting and lensing. And basically looking at finding those datums. So we had a certain datum point that was here on the drawing that we've got, looking at that datum point to these specific points that are here. And we can set up those tools accordingly here as well. So we can basically set up a datum point, use that same data point over, taking a look at some measurements here, and see where we sit in regards to the actual positions within that. This was interesting. You'll see there's a little locator tool that we'll go through looking at how we program this and configure it, where if this key was not in the exact position, we have a locator tool that will typically help locate that, and it will then put all the subsequent tools in the correct area to make your measurements. XY rotation. So we may have parts that are coming down the conveyor belt, variety of different parts. This one here, we just took an image here looking at a snack bag. So if we want to pick this off with a robot, put it into a box, we want to really get the X, Y, and rotational coordinates out of that. So what we'll do in a case like this is do a pattern match. And so basically this is a pattern matching tool that's here. So we can train it on the Doritos and the pattern that's here or whatever it might be. And as that actual part comes down, you can actually see there's kind of an XY showing the centroid in the right-hand side image here versus the one on the left-hand side. You'll see we get an XY, but we're rotated it down actually minus 171 degrees. But we'll feed this data back now to the robot or whatever mechanism we've got based on the pixel array that we've got. So we've got an XY in a pixel array, and then also a rotational value, so we know exactly. Do this. I'm trying to get my slide to advance here. There we go. Okay. So, and then looking at 1D and character recognition. Again, with vision sensors, it depends if you're just looking for 1D codes. Those are very basic sensors that are out there that you can get that are laser scanners in a lot of cases, versus 2D, very specific vision sensors that are out there to do 2D as well. Some cases, like what we're seeing here, is actually, and if we want to do some character recognition, right? So in a case like this here, maybe we have a part that we're looking at, and I just took this simple one here that I had going to read a 1D barcode. We were simply drawing a box around this, and we actually get the value out of the barcode. And then over here, do some character recognition. We draw a little box around that with our text tool, and it automatically recognizes that it says 130. So we might want to do some comparison, make sure that if a barcode was on something, it had another label that might be next to it that had the right text on it, and compare those two. So little example here where we can do some code reading and some character recognition. And there's another one here looking at character recognition, but we're doing also verification. And so recognition, as you can see in the previous example, is we're really just going in and seeing which characters are there. So in this case here, if we use the text tool, we drew a text tool around these characters that are here for the lot code, actually recognize the characters. So we have a 0024479. But the verification part comes in is that I can actually set tolerances based on good characters that are there to see if I have a bad character that's been put on. So if I've got an inkjet printer, put a date lot code, and you'll actually see here R9 is actually at about an 85% match of what the pattern or initial pattern was at. Now we can set that tolerances, right? And we might want to kick that out something below 90%, or it depends on what it is, start to fine tune that over time. But a case like that, so we're actually doing character reading, but also verifying so that you have, say, a correct date lot code as it goes out the door. In this case here, we actually use the locator also to be able to find that label and then do its chore. Another example here, we're actually looking at a 2D code plus a little bit of presence and absence. So in this case here, you'll actually see these are 3 different image shots. Reading a 2D matrix code that's here, and so a little bit different. We've got a locator tool, so as this part comes in, we can actually locate it on its edge. It was pretty good in its vertical dimension because it sit properly on a line. And then also look at the cap. Is the cap still on there? So what we use for tools here is really a 2D reading tool. So we're going to draw a box around that, and it's going to automatically read that. Then we're going to draw another box around this cap up top here and actually look for dark pixels. I've got an X amount of dark pixels that are here that would show up if it is a correct part, and the cap is on there versus not. So over here, my cap is missing. I've got a lot more bright pixels versus dark pixels, and I can kick that off. So again, we could use digital I/O for this. If I wanted to, I can actually start talking about using Ethernet communications to actually get the data out itself. So if we actually wanted to read the matrix code, bring that data out through an Ethernet, we can do that as well. So really looking at 3 main steps. Number 1, again, we need to look at getting an image, getting a good view of the part that we want to see, and getting good contrast. So from there, when we start talking about how do we easily conduct this quality check using a vision sensor, I'm going to take you through kind of the steps that you typically will see here in a vision sensor. And number 1 is really adjust the image. We're going to talk about lensing lighting again, talk about some parameters that we play with. And then the fun part comes in is really applying feature check tools from dimensional to pattern match, as we've seen in some of these examples. We'll look at configuring our interfaces, so we can take a look at what the I/O is maybe we want to do, or maybe bring that data out through some Ethernet. Then we're going to activate, and we're going to load those programs onto the vision sensor, and it's going to truly act like a sensor at that point. If we decided not to use Ethernet, we could unplug that. Just going to have a cable providing that communication and digital I/O down. So step 1 is, again, adjust image, different parameters that we're going to start to play with here, and we'll go through this. So we're going to talk through these next 4 tabs: adjust image, check features, configure interfaces, and then activate. So on the first one here, a couple different things we can go afterwards is we get a couple parameters we can play with. Typically image acquisition, you can free run it in a mode, but in normal cases on a conveyor line, you're actually going to have a drop down here that will actually get to a trigger. So typically your part will come down a line, you're going to trigger, it's going to take that picture at that specific moment and apply those tools. We can play with sensitivity in a lot of these, and in this specific unit here, we actually work with doing edge detection sensitivity. So we talk about contrast, and what contrast is key here is that when we take a look at this, you'll actually see a little bit of blue around some of the edges that are here, and it's constantly going in and taking a look at those specific edges, finding that. So it's doing this work in the background behind you. We're going to get a good image, and if we've done a good job on contrast, it's going to help us find those images so we can do some processing and apply some tools. A couple other things that we see here. One is this little slider bar here is actually for exposure time. And what exposure time really is just like thinking about your SLR camera. If you're going to take a picture of a car going by on the road at 100 miles an hour, we want to basically stop. We make a nice still image so we can see it. We don't have any blur that's in there. In a lot of cases, we'll want to do this. We'll have a very short exposure time. So in this very quick instance, we're taking a picture and stopping blur. In cases that things are static, not as much of an issue. You need to be concerned with this if you do have parts that are moving. Some other typical adjustments you may see here is gain, which helps brighten the image, but adds some noise to the image, which we need to be careful of. We can take a look at things in full resolution, which will give us a certain speed that we can do, or what we call frame rate, versus maybe doing some binarization, or actually bringing the pixels together that gives you a higher frame rate, reduces your resolution some. And those are things we can help you out with. In a lot of cases too, we have cases here we can actually drive lights for the specific vision sensors directly off the units themselves, which are available. So we're going to get into step 2 here, taking a look at the feature checks themselves. And so we want to go here, we'll basically click on our feature check button, and we're going to bring up a dialog box. And we're going to go through each one of these guys in regards to working on your first step is, do you need a part locator? If it is moving around, we definitely want to set up a part locator. Work on some geometry tools, feature comparison tools, and identification tools. So we basically have a part location, and we'll see when we go forward here, this part's going to go around in various different orientations, and we're going to actually locate each of the tools onto a locator. But basically, there's part locators on contours. We can do things on edges if things are shifting a little bit, such as that little vial I had. We can use the part locate on the edges. We can do a part locate on a circle, and also a part locate on a text line. If we look at some of the geometry tools we've got, we can do a variety of things here too. We can do some measurement, so we can look at a distance. Look at circle, which basically looking at the size and alignment of a circle. We can actually look at the roundness of a circle as well. So somebody wanted to look at lug holes in a rim once, and we can look at the roundness of that. Look at angle, see if the specific one, we're going to measure this part over here in a minute. Look at the angle of that specific part and see that that's correct. Maybe do point position. Actually gives us the coordinates of a part in an absolute and relative, depends on how we decide to do it. And a host of feature comparison tools. So you saw one with that little indent on the metal. We're actually doing a counting contour points. So we're looking at those transitions and actually counting the pixels, making that contour for some comparison. Or maybe actually contour comparison itself. So if we look at a specific shape and it might be a left-hand or right-hand part, we might use a contour comparison tool, and it's going to have a reference and then go from that reference and look at deviations. Some other basic tools that are here looking at brightness and contrast. These cases here we're looking at really looking at average brightness of something. So if you had a screw that should have been in this location, you've got an average brightness that's coming off, and all of a sudden it's missing, it's going to change. So we can again look at the analysis there. And area size and count areas is really again looking at total area size of number of pixels, of bright pixels or dark pixels we've got, or maybe looking at basically call it a blob, if you will. Do I have a certain number of areas that make up a certain amount of pixels? We can determine that. I'm going to run through that in an application here in a minute. And looking at pattern comparison and see I got a certain given pattern. From that, do I now have the same pattern or is there a deviation in that? Lastly, identification, looking at barcode, 2D matrix code, or reading text. Again, OCR, OCV in the text. And barcode and matrix, we can actually grade those codes as well. There's some actually ANSI standards and AIM standards that are out there if you're living in that world of doing some barcodes and matrix that are there that can help us as well. So let's do a little application here. We're going to work on this one part that we've got at hand here, and we're going to do a variety of things with locating the part, measuring, taking some angles, and looking at the holes. Make sure we get a good part that's here. So first step here will always be to do a part locator. And again, unless you have something that's very specifically fixtured, we want to put a part locator on here. So we're going to click on our part locate on contours here. We're basically going to draw this little box that's here, and we click here and we drag down to the right hand side and we'd have a box. And what it's going to do is, because we have in the background going on looking at all the contours, it's going to show us our model over here. And so we have a model of what's going on, and this is what it's going to go look for. We can actually edit that model using a little eraser and go and change some things if we know that some things are inconsistent. We can help really look at what that model looks like. And then we're going to hit the teach button. And we simply hit teach, and we're off to our next step. So we've actually located our part. We want to now go in here and let's take a look at geometry. So let's measure this, and we could put multiple tools that are on here. We could actually go up to 32 tools if we'd like and really do a lot of measurements on one part. Mind you, multiple tools add up to time. You'll see this in the end. Each tool has a certain time that we'll take. So typically we'd never do 32 tools, but the ability is there if you do have plenty of time to do it. Plenty of time still is typically less than a second to be able to get this done. So we'll click on Geometry tab here. we're going to click on our distance. And what we do here is we draw a line, and we basically come in here and draw that line down, click and drag, another click and drag, and we find that edge. And basically it's finding that transition. If we've done a nice job in regards to lighting this was easy because we can do some front lighting off of a relatively matte white part versus a black background. We've got relatively good contrast that is here. And so what we have after we do this is it basically automatically tells us that we've got this distance from this point A to point B in 301 pixels. If we actually had calibrated this in a first step, which we didn't have time to go into today, we can actually put that into real world units in inches and millimeters and be able to tell you what that is. From there, you can basically give it a tolerance and say it should be plus or minus X, and basically it will measure to that for you. Little calculation method here, we're actually doing a rectangular distance. We get some other conditions that we can look at here that we won't get in depth in this first webinar, with looking at edge length, looking at how much of an edge that we're seeing here to get a best fit line that's on there. Transitions, really looking at, are we going from bright to dark across this transition? Normally, in a lot of cases here, this will automatically default for you and get you on to the next step. So we get a distance. We go over here and hit the teach button, and we're on to our next step. And so let's pick angle. So the next thing we want to do is take a look at measuring the angle of the part. And so we're going to come over here, hit geometry, click on angle, and basically do the same thing. So we're going to drag and drop a line across here, put some soft tools on here, and what we're going to end up seeing is our result. We're actually getting an angle, and it's going to measure it to us for 134.88 degrees. Calculation method here is actually, as we see, angle between two edges. We can actually do an angle to a reference point. So if something is moving left to right, we could actually look at that as well. And here's some additional of our conditions that are here that we could additionally play with. I'm going to go over here and hit a teach button, and we've saved that tool now as well. So one last thing we maybe want to do here is look at the holes. Let's make sure that all these 5 holes are within this. So let's go over to the feature comparison tab. Let's go down here and use the count areas tool. So our count areas tool is basically, we typically call it a blob in the machine vision world. Is we're going to look for a certain number of blobs, and these blobs will consist of a certain amount of pixels that are all typically about a similar grayscale value. So these were all dark back here, versus its front side here. And we draw that tool across there. We're actually going to drag and drop that box that's here. And once we do so, I'm going to basically have it automatically come up and tell us that, hey, we have 5 blobs or 5 areas that we've detected. And we could depend on our min and max here, and this is typically what you didn't see in some of the other graphics, is there's usually a tolerance here that we will plug in. And then we can set a binary threshold. And what this is, and a lot of times this will just default for you, so you normally don't hang with it too much. But basically says that we're looking for anything that are dark on bright pixels that are lower than a certain value, right? And so we have that to play with. We also have an area filter, and what this is doing is saying that I want to look for any blobs or areas that within a pixel count of 50 within an area to say 6,070 or so. And we can play with those. So we actually could back that off and make it so we don't see the small circles if we wanted to, but in this case we want to make sure that they're there. And last thing we do, as we do with all, is hit a teach button, and we're off on our merry way. So what we've basically done is taken this part that we've taken an image of, did a location of the part, we checked our distance of that part, we looked at the angle, made sure that our 5 holes that are there. And so now if I was to set this up appropriately and put this on my line, we're going to see this thing rotate around. All the tools will be located based on our part locate tool, and we'll see that we'll rotate it around. Again, different orientation, and upside down. So we can actually pick this up 360 degrees. So our feature checks are done at this point, and so we've got all our tools operating, we've got our lensing lighting set up correctly, we've got our tools applied. So now what? So now is step 3. We're really taking a look at configuring the interface here for what we want to do with the results. We can have some output results of 2 different kinds here. We can take a look at discrete I/O. We can take a look at actually giving the data out. So it depends on what we want to do with the results. get some distances out, put this into statistical process controls, and let's take a look at each one of those guys. So first one here, we'll look at digital I/O. In this unit here, we actually have 5 discrete I/O. So we can actually apply some Boolean logic to some of this as well. We can see a couple things here. We'll work on our I/O, setting this up. We can play with timing of that I/O. So after it gets triggered, if the I/O goes off, maybe we have an output at a certain distance after that. We're going to work on the output process here, and we're going to skip over here and talk about the web interface a little bit. We can actually have partial results in some of these cases. So maybe output 1, we want to say, hey, did all of those tools pass? Give me an output for that. The second one may be, hey, I want to look at just a partial result and see partial result, maybe plug it as in as 1, maybe 1 partial result 1, maybe the hole's absent. Then I can maybe go rework it and I can give an output for that. Maybe number 3, we decided something else, that the holes are, if we actually measured the holes, maybe too big in a case, that we want to put it in a scrap. And we can actually work on our logic to sort those accordingly. If we actually connect with Ethernet communications, and we can do protocols out there with TCP/IP, working on Profinet and Ethernet as IP as well for communicating with PLCs. The results get communicated, right? So on this here, unlike the previous with I/O where we had just had 1 cable, I/O and power, we still need a second cable that's going to take it down through the Ethernet. But what we can do here in this output process is basically give a bunch of the data out. So in this guy here, I've got part locate on contours. We can look at the center of the object. We can actually do a part locate, look at getting out the angle of the object, get the distance and the angle information. And basically that's what we start to see as long as we have those activated in our communication screen we've got out here. So I'm basically giving it XY values, my rotation angle, because this was pretty flat and straight, 0.02, giving my distance and giving my angle. And so we can use some of this for, again, process control as we start going along and seeing that. Another part of our configuration in our interfaces on configuration interfaces here is really looking at a web interface, right? So if we want to do some things where once we've got this set up, maybe we want to set up so that we can program it, it's running out on the floor, we want to dial it in with a web browser, we can dial up the IP address, and I can program it and I can configure this. So basically I have certain buttons that show up on my touch screen or on a PC, and I can assign those buttons. So I might want to assign the button to look at angle if I click on that. Let's look at the position. Let's look at the actual dimension that's there, etc. Actually, I can set this up so I can do change jobs as well. So if I had multiple jobs that were there, I can do that through the touchscreen. And then a lot of times give the different users the ability to actually change the parameters, and there's different levels that you can gain access to. And actually look at the screen also that will give you an indication of pass and fail. So you could go by and look at the screen, say how many passed. If I've got some that failed, we want to understand why. There might be some in after our reject mechanism has taken them off. But lastly, we can also looking at the defective images. And so in the case there, we'll take a look at the defective images as an example here, but the last step is really activate. We're actually going to hit the activation. What's going to happen is it will actually save that job onto the vision sensor itself, get the option to save it onto the PC, which typically we want to do as well. And a lot of vision sensors can hold multiple jobs. In this case here, we can put 255 jobs on, be able to change in between the jobs, and be able to pick that up. So once we hit activate, here we are running. We can actually see we get a current job that's going here. We actually have a number of parts that are going by, given the resolutions. Higher resolutions will be slower speeds. Depends on the number of tools you've got. So we're actually reaching 8.4 parts per second. So essentially 8 parts per second. Number of OK, so this one here when I took it was just getting 474 OKs that went by, 474 images that passed good, and give us a little bit of information of timing that's here. We can use that as we start to fine tune and work on our application. So we're activated, we're inspecting. So every time we're snapping or basically triggering, we're taking a picture and we're going to do that inspection and for whatever tools that we applied on there. So again, we can have these multiple feature checks that are here applied to check really every part as it goes down the line and really check for quality and make sure something maybe isn't going awry upstream. Again, if we're doing measurement, we might want to see that things are shifting and deviating a little bit. We can put that back, analyze some of that data, and maybe see that a tool is being worn as an example. So continuous feedback, reject of bad parts. Here's actually a little example here that I had set up with the web browser. Pull up the IP address that I had here on this bottle, and you can see here that I actually had let it capture a handful of shots. 451 were okay. If I had had a bad part, we'd have an X amount of non-okay that's here. And this one here I just set up to look at the expiration and put a locator in case this bottle was moving, because I want to make sure that is always in the same spot to be able to pick up that text. Then we can also monitor this. So we don't have to be out there on the floor. We can actually pull it up on the web address, the web browser, which is nice, and be able to see if something happened. We say, geez, we've got a bunch of defective parts that went through. What's happening, right? Well, somebody maybe came by and decided to tinker with the aperture or light, or something got bumped. We can see here, these are all the defective images that I had. Somebody went out there and kind of messed around with things a little bit, and we're actually got too much saturation in the brightness now. It's actually still fine in the bottle, but you can see this is in red here, and we can't see that. So in summary, you can get some sense here of what's going on. We're really looking at helping improve the quality using automated visual inspection. Taking a picture, analyzing that image. Again, lighting is a key thing for you here, but really help eliminate defective parts that are going down the line. Take a look at processes as they might be going awry ahead of time, so we can help eliminate scrap. And really look at a variety of those feature checks. Again, keep in mind vision sensors are limited in some ability, but there's lots of applications that we can do with them. As we had talked about, looking at absence and presence, so measurement, part orientation, verification, OCR, OCV, etc. So, and really then, again, the big key thing here is, yeah, we can do all that, but what do we do afterwards, right? We really want to get some feedback, maybe look at the I/O, communicate to other processes, and be able to get that information back out to our control systems. So,
thank you, John. That was really good.
Thank you.
All right, so if you have any questions for John or me, you can find his contact information on the screen right now. And right now we're going to open up the remaining time for questions. So to start off, John, could you go back and clarify how does the Biomer software identify defects relative to the design parts specification?
To the design part specification? Yeah. And it depends on really what it is, right? If we had a specification like, say, the key, for example, we'll actually, if we're doing a measurement, if we're actually doing a dimensional application, right, we'll actually want to do some calibration in that example. So we'll typically get a calibration target. We'll get our vision system set up, put a calibration target will actually help us get a pixel world into real world coordinates. So we say on cal targets there's dots. We tell where those dots locations are, bring us into the real world. And then depend on what that is now, say the key example, we know that that dimension should be X plus or minus a certain tolerance. Once we have that, we can now put that into the soft tool that we've got and say it should be, say, 50 millimeters plus or minus, half a millimeter, just for an example, right? Or give a correlation value. So if it might be a pattern match, if you looked at the percentages that we looked at, this is an easy example, looking at OCR, one of those characters was at an 85% value. I can actually set it so that that value is a certain tolerance, essentially. So it's a certain match to that. So it really depends on what we're doing for measurement versus more of a correlation or a matching type value. Okay. Hopefully that answers the question.
Okay. If you wanted to check a 3D object, would you have to rotate the object or the camera?
Well, you could really do it either way. You could actually, I've seen it done that people have put in smart cameras on the robotic head itself and have it go around and look at a part and do various inspections. So if I had a three-dimensional part that was going down a line, maybe I've got a robot that goes up, positions it, looks at that part on the side, looks at some specific features, looks at another part, another different features, looks at another aspect. If it's a big part, that may be the case. If it's not, I've had people actually present parts to the cameras themselves and be able to pick it up. So it's all down to mechanics themselves of the size of the part and what's more economical for the handling aspect of things.
Okay. And can a vision sensor be used to detect the presence of adhesive?
Yes, and actually, lighting. Really, when it comes down to lighting, plastics, adhesives, glues, things of that nature actually fluoresce under ultraviolet light in a lot of cases. So if we've got some adhesives that are there, and it can be even very thin, low viscosity type fluids, if you will, if those actually fluoresce, we could pick that up. And then again, we're just pixel counting, right? So we can go and look at bright pixels versus dark pixels and tell you presence and absence.
Okay. And I know you mentioned earlier that a lot of these vision systems seem to operate in like a monochrome color scheme, but can the systems detect changes in colors?
Yes, and there's two ways that we can do this. It depends if we're looking at color to see that I have something red versus yellow. And in that case there, if we, again, back to lighting, if I use a certain color light, it could actually make red become very bright and yellow become very dark, and then I can see those changes. So a lot of times with the lighting, if it's enough difference in the grayscale contrast itself between those two colors, and we can use different wavelengths of light and colors of light to emphasize that, that's one thing, and we can do that in monochrome. There are color sensors where actually Bombers just released its color sensor, where we're using vision to be able to detect colors as well. So we can actually go and train, if I had two very close colors, let's just say I had yellow and I've got a light blue next to it, right? In grayscale, they probably look very, very, very close. But if we, in color, we go in and we look at that and we look at the hue saturation values of each of those two, we can actually pick that up and then put that into color space and then detect it with a vision system. So it really depends on how close you want to look at colors.
Okay. And say you were trying to inspect a mechanical part. Would you compare the part with, say, one of the detailed drawings of the part, or would you need something like a prototype almost?
No, I mean, you could just like the key, back to the key example if you want, right? I mean, that had some dimensions that are on there. You know what those physical dimensions are. Again, that when we get into that really gets into calibration. We need to make sure that the vision sensor, once the lensing is steady, we've got it well fixtured, we've got our lighting correct, we've got very good contrast on those edges, we can calibrate that. And once that's calibrated, now I've got real world coordinates. And I can look, if I've got edge A to B that is a very good high contrast, once I'm calibrated, I can now get that value out and then compare it. And on my drawing, it might say 50 millimeters. I can put that 50 millimeters, basically a plus or minus a certain tolerance that's in there to be able to do that.
Okay.
I mean, that just as an add-on to that, that being said, if you did have a part that was, say, an inch long versus 1.2 inches long, and it can actually be shorter than that, we could do things that you could easily just look at that in pixels themselves and see, has it changed in its height? So it depends on what level you want to get to. We would call it just general measurements, gauging, which is a whole different world.
Okay. All right. Well, if you have any more questions for John, or again, myself, you have his contact information there on the screen. And with that, I'd like to thank everyone for attending today's webinar from Design World. And as a reminder, this presentation will be emailed to everybody in the next few days, and will also be available on our website, which is www.designworldonline.com. If you'd like to discuss this topic further, feel free to stop by the engineering-only site, engineeringexchange.com. Just go ahead, log in, ask your questions, and we'll try to get answers for you as quickly as possible. So thanks again, John, for taking your time to speak with us today.
Great.
Great.
And thank you all for attending.
Yeah. And everyone, have a good day.
Thank you.